Okay, let's assume that this transistor is in the saturation mode and let's try to get the outputs in that case. Okay, so in the saturation mode, the base emitter junction is in forward bias, which means that the drop in the base emitter junction is going to be 0.7 volts, which means that the emitter voltage is going to be 6 minus 0.7, which is equal to 5.3 volts. In the saturation mode, we also know that the voltage VCE, the voltage between the collector and the emitter, right? The voltage between the collector and the emitter is 0.2 volts, which means that the collector voltage is going to be 5.3, which is the emitter voltage, plus 0.2 volts, which is equal to 5.5 volts. Okay, and now having these voltages we can calculate IE. So what is IE going to be? IE, we did it last time, it's going to be 5.3 divided by 3.3, which is 1.6 milliamperes, and you can calculate IC, and IC is going to be what? If you want to calculate IC is going to be equal to 10 minus VC over 4.7K, and you can put the values in, and I think what you would get is that this is approximately, this is equal to 0.96 milliamperes. That's what IC is. Okay, so and now if you want, you can check whether this transistor is actually in saturation mode, and you can take a look. So this is 6 volts, this is 5.5 volts, so the drop is around 0.5 volts, which makes sense. This is forward biased, the base collector junction is forward biased, and similarly the base emitter junction is also forward biased. So this solution seems to be right, and the transistor is in saturation mode.